Right now, as you watch this, something is dying. A machine older than most of you is limping through the darkness beyond our solar system, running out of power, running out of time. Its heartbeat is fading, and a team of just 10 people is the only thing standing between it and eternal silence. This is not science fiction. This is happening right now. Here's what breaks my brain. I can't get a decent signal in my own kitchen. But NASA is holding a conversation with something 24 billion kilometers away. A signal left Voyager 1 almost 24 hours ago. It traveled at the speed of light, all day, through nothing, through absolute cold and darkness, and it just arrived. How is that possible? It starts with a miracle hiding inside mathematics. In 1964, a young student at NASA's Jet Propulsion Laboratory was staring at equations when he saw something extraordinary, something that only happens once every 176 years. Jupiter, Saturn, Uranus, Neptune, all four giants lined up like stepping stones across the solar system. A spacecraft could surf gravity itself, bouncing from planet to planet, using each one as a slingshot. A journey that should take 30 years could be done in 12. They called it the Grand Tour, and they almost didn't build it. After the moon landings, budgets were slashed. 4 probes became two probes that would carry something deeply human on board, a golden record. Music, voices, the sounds of Earth, a message in a bottle thrown into an infinite ocean. Voyager 2 launched first. August 1977. Voyager 1 followed weeks later, faster, hungrier, aimed like a bullet at Jupiter and Saturn. Together, they showed us things nobody had ever seen. Volcanoes erupting in space on Jupiter's moon Io, the rings of Saturn up close for the first time, Uranus, Neptune, worlds visited once and never again, and then they kept going, forever. So how do we still talk to them? Each Voyager carries a dish antenna 3.7 meters wide. Behind it sits a transmitter running on roughly the same power as the light bulb inside your fridge. That tiny flicker of energy screams across 24 billion kilometers. By the time it reaches Earth, the signal arrives at less than 1 attowatt. That's a billionth of a watt, 20 billion times weaker than a watch battery. To catch that whisper, NASA built 3 of the most powerful radio antennas on the planet, one in the California desert, one outside Madrid, one in Canberra, Australia. Spaced equally around the Earth so that as we spin, at least one dish is always facing deep space. The receivers are cooled to just 4 degrees above absolute zero, because even the faint warmth of electronics would drown out Voyager's voice. And even then, they can barely hear it. What nobody tells you is how many times we almost lost them. In 1978, just 8 months after launch, someone on the ground made a scheduling error. Voyager 2 went silent for 7 days. The spacecraft panicked. Its software assumed the main receiver had failed and switched to the backup. The backup had a broken capacitor. It couldn't lock onto Earth. When engineers forced it back to the primary, the fuses blew. The primary receiver was dead. Voyager 2 was stranded, 8 months into a mission designed to last 5 years. But the team in Madrid refused to give up. Hour after hour, they swept through radio frequencies, searching for the exact tone that broken receiver needed to hear. And then Voyager 2 phoned home. That desperate workaround from 1978, Voyager 2 has been using it for nearly 50 years. Then in 2022, Voyager 1 started sending back gibberish, pure nonsense. The team was baffled for months. Eventually, they discovered it had been accidentally routing data through a dead computer, one that hadn't worked in years. And in 2023, Voyager 2 went completely silent for 2 weeks. No signal, no heartbeat, nothing, just gone. The only antenna that can even reach Voyager 2 is the one in Australia because it left the solar system heading south. No backup, no second option, 2 weeks of silence. Then a faint blip, a heartbeat. The next day, NASA did something they called the interstellar scream. They cranked the transmitter to 250% power and fired one single command across the solar system, across the void, and prayed, "Aim your antenna back at Earth," and it worked. Here's what gets me. All 6 of Voyager's computers combined have 68 kilobytes of memory, less than a car key fob. Your phone is 2 million times more powerful. And yet a team of 10 people has been nursing these machines across the darkness of space for 48 years. Every year they have to make a choice which instrument to shut down to save power. They are choosing which eyes and ears to close on a spacecraft that is never coming home. The plutonium is almost gone. The power is fading. We have maybe 5 years left, maybe less. When the last instrument finally goes dark, when the signal fades to nothing, the Voyagers won't stop. They'll just go silent. Two tiny machines, smaller than a car, drifting through interstellar space at 17 kilometers every second, carrying photographs, music, human voices, the sound of rain, a mother's first words to her child. Long after every person who built them is gone, long after we are gone, they will still be out there, carrying the story of everyone who ever lived on this planet into a darkness we will never see, toward stars we will never reach. And if something out there ever finds them, they'll know we were here, they'll know we were curious, they'll know we were brave, and maybe, just maybe, they'll know we were beautiful.